Today we're going to learn section 6.6, mixed expressions. So we're going to start out relatively simple, writing each expression as a fraction in simplest form. So we want to write that as a rational number, that is the quotient of two integers. So what we do is we take the denominator, multiply it by the whole number, 5 times 4, and then we add the numerator. So that gives me 21/5. If we think about it, we have 4 and 1/5. We have 4 plus 1/5, and 4 can be written as 20/5. So that's how we get 21/5. If we want to look at it even more specifically, 4, that means we have 4 whole figures broken into 5 pieces. And they're all shaded in because they're complete ones. So we have 5 pieces, 5 pieces, 5 pieces, 5 pieces, 5 pieces, or 4 times 5, which equals 20/5. And then we've got that one extra that is shaded in. So that's how we get 21/5. So we do the shortcut, taking the denominator 5, multiplied by the whole number 4, and then add the partial piece. Now, when we have these two pieces, we have to have common denominators. So we're going to write 8 as 8 over 1, and we bring down 1 over x. We notice that we don't have common denominators. When we did our first one, we noticed that we had to have common denominators in order to combine their numerators. So this task is asking for us to find a common denominator, or a least common multiple, LCM. We remember that our denominators, or LCD, is 1 and x. So we're going to break it into its prime factorization. What do they have in common? They have nothing in common. Then we have our leftovers. These are our leftovers. So our least common denominator is going to be what they have in common, which is nothing, and then what they have left over. So our LCD, or our common denominator, is going to be x. So we were able to find the common denominator. Now we have to find equivalent fractions to it. So we have 8 over 1 is our original fraction, and we want to find an equivalent fraction with x in the denominator. So we ask the question, 1 times what gives me x? 1 times x. So if I multiply the denominator by x, I have to multiply the numerator in order to keep it equivalent. So this is an equivalent fraction. 8 over 1 is equivalent to 8x over x with the denominator of x. And we see that we already have in my second fraction the denominator is already x, so the numerator won't change. Now that we have common denominators, we can combine the numerators. What we see here, however, is that those are unlike terms. So we cannot combine 8x with 1. So we have to write 8x plus 1 over x is that fraction written simplified, added, combined. Same thing. We have to find a common denominator. Sorry. So my denominators are 1 and a. If I get really good, I should be able to figure out what the common denominator is. 3a over 1 equals what over a? We're going to multiply by a. We get 3a squared. That's going to stay the same. We have common denominators. Same denominators, so now we can combine their numerators. So 3a minus 2 over a simplifies to 3a squared minus 2 over a. Our denominator now used to be a monomial, now it's a binomial. We're still doing the same technique. If we look at our LCD, we have 1, prime factorization is 1, x plus 2, its prime factorization is x plus 2. I can't simplify, I can't break those out. So what do they have in common? Nothing. What do they have left over? They have a 1 left over and an x plus 2. So my LCD is going to be technically 1 times x plus 2, which equals x plus 2. So a common denominator, x plus 2 minus x plus 2. We want to find equivalent fractions. My equivalent fraction, 5 over 1 equals what over x plus 2? 1 times what gives me x plus 2? Well, x plus 2. What I do to the denominator, I need to do to the numerator. And then I'm going to distribute, I'm going to simplify that out. So the common denominator of 5 over 1 now will be 5x plus 10 minus 4 over x plus 2. We have the same denominator, so what can we do with the numerators? We can combine them. We can put them on the same line. This time we do have like terms, so this problem becomes 5x plus 6 over x plus 2. The numerator cannot be factored, the denominator cannot be factored, so that's my final answer. The last problem that we're going to do in part 1, the common denominator is going to be n plus 1. This becomes 8n over 1 equals what over n plus 1? We have to multiply it by n plus 1. We're going to distribute. We get 8n squared plus 8n. So that numerator we have like denominators. Combine the numerators. 8n squared plus 8n minus 2 all over n plus 1. This is a place where most students forget to do. We see that we have 3 terms we want to factor, but notice first that we can factor out a common term. Factor out a 2, we get 4n squared plus 4n minus 1 all over n plus 1. Now we want to see if we can factor this. So we're going to do a times c, 4 times negative 1 gives me negative 4. My signs are different. Factors of 4 when subtracted equal 4. So we have signs are different. Bigger is positive, negative 1, positive 4, negative 2, positive 2 gives me 3, gives me 0. Neither of these equal my middle. So this would be my final answer. But we always have to check and make sure that we have factored the numerator and denominator completely.